Example 1. So we want to find the sum of the first 8 terms of this series. And if you look at the numbers, they seem to be multiplied by 4. And so we know that this is not just any series, it's a geometric series, where a is going to be equal to 2 and r is going to be equal to 4. And we're finding S8, so n is going to be 8. So then what we have our formula, which is that the sum of the first n terms is going to be a r to the n minus 1, all divided by r minus 1. So the sum of the first 8 terms is going to be 2, 4 to the 8 minus 1 over, and the ratio is 4 minus 1. This might be a fairly large number. 4 to the 8 is 65,536 minus 1, all divided by 3. Times 2 equals, divided by 3 equals. And if you plug it into the calculator, you get 43,690. So that tells us that the sum of the first 8 terms of this geometric sequence, or the 8th term of the series, is 43,690. Let's do another one of those. This one's going to be slightly different. What's different about this one is that the r is negative. So we're multiplying by -3 and by -3 because it went from negative to positive, and by -3, etc. So in this case, the a is 3, the r is -3, and we're trying to find, so again, Sn is a r to the n minus 1 over r minus 1, which is going to be 3 times, and n is going to be 9 minus 1 all over -3 minus 1, which is going to be 3 times minus 19,683 minus 1 all over minus 4. And that is going to give us 14,763. It's going to be a positive because we're going to have negative on the top and a negative on the bottom. So it's going to be positive. So the 9th term is going to be positive 14,763. As a point, if I had found the 10th term, probably the sum of the first 10 terms probably would have been negative, because -3 to the 10 would have been a positive number, and a positive divided by a negative would have been negative. Example 3. So what we want to do here is you want to figure out the number of terms first. So we know that a equals 4. We know that r equals 3, and we need to find n, but we do know that t of n equals 2916. So step 1, we need to find n. So what we're going to have is, we know that t of n for a geometric sequence is ar to the n minus 1. So 2916 is 4 times 3 to the n minus 1. Divide both sides by 4. So 729 is 3 times 3 to the power of n minus 1. And believe that's 3 to the 5. Nope, it's 3 to the 6. So 3 to the 6 equals 3 to the n minus 1. The bases are the same, so the exponents are the same. 6 equals n minus 1. So n equals 7. We're going to have to continue this on the next page because we are out of room. So now that we know n equals 7, so as a reminder, a equals 4, r equals 3, n equals 7. And the sum is going to be a r to the n minus 1 over r minus 1, which is going to be 4 times 3 to the 7 minus 1 over 3 minus 1 times 4 equals divided by 2. And that's going to be 4,372. So all these numbers added together, 4 plus 12 plus 36 plus etc. following that pattern is going to be 4,372.